Okay, this is a video just to kind of talk through setting up these word problems here on this test, and a video trying to kind of explain, what are we looking for, what do we want to accomplish here. And so in problem number 4, it says Marwick Farble, great name, the great trig student, now has his sights set on a school's flagpole. If our 6-foot-tall hero is 30 feet from the pole and sights its top up at a 40-degree angle, how high is the flagpole? Draw a diagram and use trig ratios to solve the problem. So we are going to solve this problem just like we solved 1 through 3. But the difference is there's a little bit more going on. And so right now when you look at this diagram, and it's actually drawn for us, right? There's a flagpole on the left side and you kind of see a triangle there. I'm going to put a right angle here since all of these need to be right triangles. Right, we have a triangle here that we can work with. But one of the differences in the problems up here, there's already an x or a w or whatever variable you need to solve for. That's not in this problem. And so understanding what you need to solve for here is kind of a tricky thing. But ultimately, we are going to use this 40-degree angle. We're going to use this 30 feet, and then we're also going to use this 6 feet at some time. And that's going to help us find how tall this flagpole is, all right? And so really your goal is to use the 40-degree angle and the 30-foot bottom side of this triangle. And let me even try to just kind of make this triangle pop out a little bit more. And when we do that, I'm going to put an X on the left side of our thicker red line. We can figure out what this X is, right? Kind of the way we taught it in school was we circle our angle. So we circled the 40 degrees, and then we want to label this side either opposite, hypotenuse, or adjacent, whatever that might be. And then we want to label this side as well. And that will tell us, which trig function to use. Now, when you solve for that X, that's only the partial height of the flagpole, right? It's only to where this darker red triangle is. And so then that's where the 6 feet comes into play. Once you solve for X, you'll realize, well, this flagpole still has an additional 6 feet below where the X is. And so the last step you'll have to do once you solve for X is add 6 to it, and you'll be able to get your final answer. So that's kind of how problem 4 works. Now, let's move on to problem 5. Tyree planned to build a ramp from his window to the sidewalk so he could skateboard right out of his window on the way to school. His window is 5 feet off the ground, and the sidewalk is 20 feet from his house. What is the angle his ramp will make with the ground? And so angle is kind of like problem 3 up here, right, when you solved for this X. So ultimately, we'll do the same thing, but we need to be able to draw our triangle. So I'm going to draw Tyree's house. I'm not so good at that, but let's just say, here's his wall, and let's say his window is like right in this top corner. It doesn't have to be a great drawing, right? And so Tyree's gonna skateboard right out of that top corner of this spot, right? And so for him to do that, it's gonna have to be like a ramp, right? And so something like that. That would be what he's skateboarding down. And then he hits the sidewalk, right? And if I bring it back to the house, it kind of makes this right triangle. And then of course, the sidewalk continues and Tyree skateboards to school. Now, the information they give us is his window is 5 feet off the ground. And so remember, the window is kind of that black oval or circle I put there. And then the ground is directly below it. So this side of our triangle will have a 5. And then it says the sidewalk is 20 feet from his house. So let's even change this color a little bit. Right when he hits the ground, that's when the sidewalk is going to start. And so that starts, again, 20 feet from his house, which means that this bottom side of the triangle is where our 20 will go. And what we want to figure out is the angle his ramp makes with the ground. And so his ramp is the slanted side, and then the ground is this dotted side. And so if we want to find the angle, we can put our X right where those two sides meet. And then we can circle this, and we'll want to label, the 5 side, and then we'll want to label the 20 side. They'll both either be opposite, hypotenuse, or adjacent. And then you use, sine, cosine, or tangent to use sine, cosine, or tangent based on what you label those sides. Now, remember when you are using or looking for an angle, that's when we use the sine -1 or cosine -1 or tan -1. And then just a real quick reminder for all of these problems, be in degrees in Desmos. We got to be in degrees in Desmos, right? So you can click that wrench in the top right corner and then make sure the word degrees is highlighted in green. And then that'll get you into the right units as you do your calculation here, right? Now, number 6 is definitely challenging. So let's talk this one through. From the parking lot at the Red Hill Shopping Center, so that's where the cars are, the angle to the top of the hill is 25 degrees, right? And that's where you see this 25. Now, from the base of the hill, and so you see kind of these squiggly lines in here. I'll try to draw my pink marker on the squiggly lines. Ooh, that was bad. That's our hill. So the base of the hill is kind of like the bottom. So that's where you see the 55 degrees. It says from the base of the hill, the angle of elevation to the top of the hill is 55. Now, it says if Red Hill is 740 feet tall, how far away is the parking lot from the base of the hill? Now, thinking about how something, is tall, right? It's always measured from the ground up. And so 740 would be this left or right side of the triangle. Now, I want to kind of highlight this because there's two triangles here. With our 55 degree angle, that's this triangle. And then with the 25 degree angle, that's this triangle. Notice both of them on the right side have the 740, right? That's part of the triangle. And we've got our right angles right here. So basically what you want to try to do is use that 740 and then both of the angles, right? So you'll use 25 once and 55 once. And when you use 25, that's going to help you figure out this distance right here, the red distance. And then when you use 55, that's going to help you find the blue distance. And so you need to find both of those distances, but what you really want to ultimately find is the base of the hill to the parking lot, and so that's only this orange distance here. And so then once you get the red and the blue, you'll essentially want to do the red side and then minus the blue, and that's going to equal your orange. And your orange distance will be your final answer. That will be how far away is the parking lot from the base of the hill. And of course, we're using our sine, cosine, tangent in both of these. And so for the blue triangle, right, from the 55 degree angle, got to label across, and then you want, I'll put an X down here for blue. You want to solve for X. And then you go do the red one. That's across from the 25 degree angle, still 740. And then we'll put kind of a Y for red. You want to find that. And so then kind of using those symbols, red minus blue is Y minus X. And that still, of course, will equal your orange distance, which is your final answer. Now, I hope this helps. I didn't want to give you too much. It is a test. I need you to practice and show your skills. But I think this kind of gives you an idea about the setup. And once you get the setup, just remember that they're just triangles, right? And so you said that you had done these three, and so you'll just kind of solve it in the same way that you solved these three, but we just have different triangles down here. So I hope that helps. Let me know if I can answer any more questions for you, but good luck. Thank you for asking.